if we look at a case where r is in between -1 and +1, or the absolute value of r is less than 1 so long as r is not equal to 0, then we would say that the infinite sum of this is equal to the limit as n approaches infinity of our Sn, or the limit as n approaches infinity of a bracket 1 minus r to the power of n divided by 1 minus r. Now remember, when we're doing this, we have to pick a value for r that is between -1 and +1, which means that we could say that r could equal 1/2, and then r to the n would be 1/2 to the power of infinity, which is going to, as we did in the previous lesson, tend towards 0. The same thing if I said that r was instead -1/3. Then I'm going to have -1/3 to the power of infinity. And once again, this is still going to tend towards 0. So from my formula here, if I'm approaching infinity and I have a times 1 minus r to the power of n, that's going to tend towards 0. And this is all going to be over 1 minus r. So I have the limit as n approaches infinity of a times 1 minus 0 all over 1 minus r, which is just going to give me a over 1 minus r, because a times 1 minus 0 is just a times 1, which is just a. Which means that for this case, the infinite sum is just going to equal a over 1 minus r, which is solvable, which means that the sum exists and it is convergent. What about for case 2? What if r is actually equal to 1? Well, then if I have a plus a times r plus a times r squared plus yada yada yada, then I'm going to have a plus a times 1 plus a times 1 squared plus so on and so forth, which is just going to give me a plus a plus a plus a, like our 3 plus 3 plus 3 plus 3, or 1 plus 1 plus 1 plus 1. We know that this is going to be divergent. Which means that the limit as n approaches infinity of s of n does not exist. If r was -1, then that's going to give me a plus a times -1 plus a times -1 squared, so on and so forth. This is going to become a minus a plus a minus a plus a, going on forever and ever and ever. Now, this is just going to give me a sum of a and then 0, then a and then 0, then a and then 0, which means that this is going to be divergent, oscillating, which we all know means that this is going to have an infinite sum that does not exist. The last possibility is it's not in between -1 and +1. It's not equal to -1 or +1. It is going to be greater than +1 or less than -1. So I could have a number like a is equal to 3 and r is equal to 2. Let's just pick a number greater than 1. And that would give me 3, and then 3 times 2, and then 3 times 2 squared, and so on and so forth, which is going to give me 3 plus 6 plus 12 plus whatever, and this is obviously divergent. So the limit as n approaches infinity of s of n also does not exist. To summarize all this, the absolute value of r has to be less than 1 to have a convergent series. If it meets that requirement, then we can solve what the sum is, or the infinite sum is, by putting in a over 1 minus r, or term 1 divided by 1 minus the common ratio. If the absolute value of r is either equal to 1 or -1, or it is outside of there, it's going to be divergent, and the sum does not exist. Now, for reference, this formula is on your formula sheet. That's not one you have to memorize. The sigma notation, the sum going from n is equal to 1 to n is equal to infinity of term n, or term 1, or any term, is going to be a times r to the power of n minus 1, is going to be just that formula, so long as the absolute value of r is less than 1 and r is not equal to 0. This is not on formula sheet. So make sure you understand and know how to do the sigma notation. So if we're calculating the sum of a geometric series, the first thing, we should make a list. What's our first term? 5. What is our common ratio? Well, that's T2 divided by T1, or T5 divided by T4, T10 divided by T9. Take any term and divide by the term that came directly before it. In this case, we're going to say that that is -10 over 3 divided by 5, or -10 over 3 times 1 over 5, which is going to give us -10 over 15, or just negative 2 over 3. We know that because r is equal to negative 2 over 3, and the absolute value of r is less than 1, then this is convergent. That means that we can solve the sum. So we can say that the infinite sum is equal to a over 1 minus r, which means that it's going to be 5 over 1 minus negative 2 over 3, which is equal to 5 over 3 over 3 plus 2 over 3, or 5 over 5 over 3, which is the same as 5 multiplied by 3 over 5. And we can cancel out the times 5 and divide by 5. And the sum is just going to be equal to 3.